So I'm going to start with Feynman Lecture Volume 3, Chapter 1, which is Quantum Behavior. So in this chapter, I'm going to cover all these topics, but for this video, I'm going to cover first three topics. So, like we start with things on very small scale. So, whatever we think about the movements of small scale or life on small scale or whatever you think about what is happening on small scale, that nothing behaves like we have any direct experience. So we can say they don't behave like particle, clouds, billiard balls, weight on spring, or anything you have ever seen. So then question is that how they behave, how we are going to learn about them. So firstly, in if I talk about how our previous scientist approaches to this problem. So they took the behavior of light. One of the prominent scientists, Isaac Newton, sir, said that light was made up of particles. But sometime later, it is found that light behaves like a wave, and later it is found that the light it did indeed sometimes behave like particle and waves in many respects. But according to our book, we are going to focus on that it is like neither. Okay, so we know how large object will act, but things on small scale just do not act that way. So we have to learn about them in a sort of abstract or imaginary fashion, and not by connection with our direct experience. So I'm going to cover an experiment, which you have to imagine in your mind. So our first experiment, an experiment with bullet. For this experiment, we have a gun which rotates from here to here. Then and it fires a bullet at very slow rate. So after that we have a wall over here having two holes, hole one and hole two. After that we have this backstop where all bullets stops, and on this backstop we have a movable detector which detects the lumps of bullet or shells of bullet. Okay, so here we are considering that whatever arrives here, that arrives a full lump or shell, no half lumps, no pieces, just a full lump. So if I explain more that if a bullet is fired from here, then a shell, full shell must be detected here, no half shell. Okay. Now in step one, we close this hole too, and all the bullets that are now fired will pass through from this hole one, and some of them will be detected by this movable detector, but other will fall on the backstop. Now from here we calculate the probability P1. Okay, you must remember this, that it is for hole 1 open, but hole 2 is closed. Now the maximum of this P1 occurs at value of x, which is on straight line with the gun and hole 1. over here on this point. Okay, so for this step 1, we have a probability curve like this. You can see over here, and for this position we have maximum probability P1. Now in our second step, what if we close the whole one? Now what if we close this whole one, but this whole 2 is now open? Okay, so now probability P2 is written for this situation, and in same way the maximum of this P2 occurs at value of x, which is on straight line of this gun hole, and it means over here. Okay, so we get this P2 maximum over here, somewhere here. Okay, now this was our step 2. You must remember that in this situation hole 1 is closed and hole 2 is open. Now we have a third step. In this step we have both holes open. Okay, now what we see here, we detected the probability curve like this over here, and we can mathematically see that this is sum of P1 plus P2. So we can say the effect with both holes open is the sum of the effect with each hole open alone. So we shall call this result an observation of no interference. Okay, you must remember this point, that this experiment of bullet is no interference. We will discuss about it later. Okay, now move. Let's move towards next experiment, where we will replace this gun with a wave source, and this detector now will detect intensity, which is square of amplitude. Okay, so in same sense, step 1, we have hole 1, we have hole 1 open, but hole 2 is closed. It is similar to our previous case. So we find a intensity curve I1 for this case, which you can see in this graph. And let's say the amplitude is h1, so our I1 is h1 square. Okay, in step 2, you already know. Now we will close our hole 1, but hole 2 is open. Now we have amplitude in terms of h2, so our intensity becomes h2 square. Okay, in previous case we have seen that P12 is sum of P1 plus P2. So for our third step, step 3, what we did in our previous experiment, we have both holes open. So for this step also we are going to open hole 1 and hole 2 together. So whatever we detect, is I12, and it is its graph is plotted over here. Okay, so if now we are trying to mimic the previous result where we have this p12 equals to p1 plus p2, and in same sense you will say mathematically it must be correct, but our experimental result says something else. So here I12 is not equals to I1 plus I2. It is in other sense H1 plus H2, because amplitude must be added first. So you know the maths, you can do it here, A plus B. So uh, H1, this is H1 square plus H2 square plus 2 H1 H2 and a cos delta. Now this cos delta is our term which we say phase difference between H1 and H2 amplitudes. Now we can modify them for I1 plus I2, and we can write it I1 I2 cos delta. Okay, so if we have constructive interference, we can say it is in phase, and for destructive interference, it is out phase. Okay, so these are important results. So it may challenge your mental intuitions. Okay, so this is our fourth experiment, which we will discuss in our next video. Thank you.